In the vast expanse of the cosmos, nestled some 40 light-years away from our own solar system, lies a red dwarf star named Trappist-1. This ultra-cool dwarf star, 11 times less massive and significantly smaller and cooler than our Sun, is home to a fascinating planetary system. Among its 7 known planets, Trappist-1E stands out as a prime candidate for harboring life beyond Earth, if it will have an Earth-like atmosphere. Trappist-1E is part of a tightly packed planetary system, with all 7 planets orbiting their star much closer than Mercury orbits our Sun. The distance from Trappist-1E to host star is 4,300,000 kilometers. This proximity to the host star has significant implications for the planet's conditions and potential habitability. The planet is tidally locked, so 1 year on Trappist-1E equals to 1 local day, and it is 6.1 Earth days, or 146 hours. The discovery of the Trappist-1 system has ignited the imaginations of scientists and the public alike, offering a tantalizing glimpse into the possibility of finding life as we know it elsewhere in the universe. As we delve deeper into the characteristics of Trappist-1E, we begin to unravel the mysteries of this intriguing exoplanet. Trappist-1E is a rocky planet, slightly smaller than Earth. Its diameter is about 0.92 times that of Earth, or 11,735 kilometers, and its mass is estimated to be around 0.69 times Earth's mass. These measurements suggest that Trappist-1E has a slightly more density than our planet, 5.65 grams per cubic centimeter, indicating a likely composition of rock and metal. The surface gravity on Trappist-1E is estimated to be about 0.82 times that of Earth. This means that you would feel slightly lighter on Trappist-1E than you do on Earth. 80-kilogram person would weigh just 64 kilograms here. Perhaps the most intriguing characteristic of Trappist-1E is its potential for hosting liquid water on its surface, but only if it has an atmosphere. The planet's equilibrium temperature is estimated to be around minus 27 degrees Celsius. This is slightly colder than Earth's average temperature, but the presence of an atmosphere could potentially warm the planet's surface through the greenhouse effect. Trappist-1E orbits its host star in a mere 6.1 Earth days. This incredibly short orbital period is a result of the planet's close proximity to the star. Due to the strong gravitational forces at play, Trappist-1E is tidally locked to its star, much like our Moon is tidally locked to Earth. This tidal locking means that one side of Trappist-1E perpetually faces the star, while the other side remains in perpetual darkness. This could lead to extreme temperature differences between the two hemispheres, with one side scorching hot and the other frigidly cold. However, if Trappist-1E possesses a sufficiently dense atmosphere, heat could be distributed more evenly around the planet. So far, we do not know if the planet has an atmosphere. What we do know is that the planet does not have hydrogen-dominated atmosphere, which leaves some hope for more Earth-like atmosphere. This would create more temperate conditions across the surface, potentially allowing for the existence of liquid water. Section 4. The dim parent star. The host star of Trappist-1E, Trappist-1, is an ultra-cool red dwarf star. It is significantly smaller and cooler than our Sun, with a radius of about 1/10 that of the Sun and a mass of only 8% of the Sun's mass. It is slightly bigger than Jupiter. Red dwarf stars like Trappist-1 have much longer lifespans than our Sun, burning through their fuel at a much slower rate. This longevity could provide ample time for life to evolve on planets orbiting these stars. However, red dwarf stars are also known for their intense stellar activity, frequently emitting powerful flares that could be detrimental to life on nearby planets. These flares release bursts of high-energy radiation that could strip away planetary atmospheres and even boil away liquid water on the surface. Section 5. Potential for life. The possibility of life on Trappist-1E hinges on several factors, including the presence of an atmosphere, which is not confirmed yet, the planet's surface temperature, and the level of stellar activity from the host star. While the planet's position within the habitable zone is promising, it is not a guarantee of habitability. The habitable zone, also known as the Goldilocks zone, is the region around a star where conditions are just right for liquid water to exist on the surface of a planet. Trappist-1E resides within the habitable zone of its star, but its tidal locking and potential exposure to stellar flares pose significant challenges. Also a terminator zone, transition zone from permanent day to permanent darkness, might be good area for some simple life forms. Despite these challenges, Trappist-1E remains an intriguing target in the search for extraterrestrial life. Its Earth-like size and potential for liquid water make it a prime candidate for further study. Section 6. A distant cousin. Based on our current understanding of Trappist-1E, it is likely a rocky planet with a solid surface. However, its appearance remains a mystery. The planet's potential for clouds, oceans, and continents is unknown. While Trappist-1E shares some similarities with Earth, it is important to remember that it is a very different planet orbiting a very different star. Its tidal locking, intense stellar radiation, and unknown atmospheric conditions make it somewhat skeptical. Place, probability of life is less than 5%. My personal verdict is that it does not have an atmosphere, does not sustain a life, and looks more of like huge moon. However, despite the uncertainties, the discovery of Trappist-1E and its neighboring planets has ignited imaginations for many. It serves as a reminder that our galaxy is teeming with planets, many of which could harbor conditions suitable for life. This is all for today. As we continue to explore the cosmos, we may one day uncover the secrets of intriguing exoplanets and perhaps even find evidence of some form of life beyond our own pale blue dot. If you have different opinion, please tell us, subscribe, and leave comments.